Hello everybody and welcome to today's webinar, How to Modernize Your OpenEdge Application. This webinar will be presented by Nikolai Vasilev and we will open up to a live Q&A at the end.
Thank you, Emily. So, hello guys, my name is Nikolai Vasilev. I'm a senior solutions engineer here at Progress, specializing in app modernization and specifically cloud evolution. Today's session will be on how you can modernize your OpenEdge application. So without further ado, let's move right into it. We're going to take a look at the state of modern cloud-enabled applications. We're going to see what are the 7 pillars of a highly functioning and performing cloud-enabled application. We will discuss the recommended cloud-enabled architecture that you can achieve with OpenEdge as well. You will see how you can leverage your existing business logic to build highly scalable and testable applications. And of course, we will go into how you can optimize your UI development by leveraging headless architecture design and REST APIs. The fact is that the OpenEdge community is not the only one that feels the pain of legacy applications. Application modernization is an industry-wide problem that is faced by every application out there, regardless of the underlying platform. In fact, according to Gartner, within the next 4 years, 90% of current applications will have been insufficiently modernized to address today's and tomorrow's demands. We've been stressing the importance of the modernization with our OpenEdge partners and customers for years. Some have jumped all in and led the charge, pushing us to move and deliver faster to support their business needs. Others navigate through the process, weighing pros and cons and trying technology approaches here and there, but many do not move forward, overwhelmed and paralyzed by the effort. Gartner actually recommends something called continuous modernization, or what we now call application evolution. It's a prescriptive planner for updating the application in a continuous way to deliver value to the business. To do so rapidly and in an agile manner, the application has to be broken up from a monolithic architecture into a lightweight one of various services or components. This makes the application more suitable for the clouds. An API-first approach eases the extensibility and provides access to various connections, data sources, applications, and platforms that make up the IT ecosystem. With that said, let's take a look at what the 7 evolution imperatives are and how they make up the ecosystem of a modern application. Starting with extensibility and integration. This is basically the application's capacity to append additional functionality without affecting its structure, but also refers to its ability to share and to extend both information capabilities and data across connections. So it refers to architecture, microservices, as well as data connectivity. Scalability and performance go hand in hand because as the application begins to grow in number of users and connections, its ability to scale is dependent upon its ability to maintain performance as a result of that growth. Next, availability is the application's measurement against the goal of continuous uptime and avoidance of data loss due to a disaster or a breach. And the standard for this measurement has grown immensely in the past couple of years, starting from days of acceptable downtime. Now we are at the 5 nines, or 99.999% uptime, which is about 5 minutes of unplanned downtime per year. This is the standard nowadays. Moving on to security. This imperative is the organization's ability to protect the system and the application from unauthorized users while staying in compliance with government regulations. One of the latest examples for this is GDPR. Usability should be a consideration with all of these imperatives. And this refers not only to the application, but the organizational processes, people, and procedures that surround its development lifecycle. When thinking about agility, you don't know what will stick in terms of technologies and tools, so you have to be able to adapt in an agile manner. This is tightly coupled with the extensibility and integration principle from the previous slide. As we now understand why it has been difficult for the OpenEdge community to evolve their applications and the expectations or requirements for the application, we actually formed a cross-functional team that was established to help ease the burden of application evolution. The following slides will show what the team came up with. I think we're all familiar with this OpenEdge reference architecture view. This has been shown on various user group presentations and workshops throughout the years. The primary goal of this was to talk about separation of business logic from the user interface. And this is still very applicable today, but these days we're also talking about evolving applications from monolithic architecture into a componentized or modularized microservice architecture. So perhaps this is a more accurate depiction of those principles. This is certainly reflecting better modern best practices, but it's still somewhat simplistic. Making that move from a monolithic architecture to microservices has a broader impact than you might expect. When you have an end tier and then expose REST APIs, you can then start to grow those into the appropriate microservices to enable this module-based microservice architecture. And that's not just beneficial from an application development and maintenance perspective. It lays the ground for you to be ready to deploy those lightweight, typically stateless microservices in containers. You may have already made the move from physical servers to virtual ones, so deploying into containers is a natural next step. It has efficiency benefits to get more out of your physical machines, but typically it's beneficial because you can spin up containers very, very quickly. And one of the reasons they're used in that way is in modern DevOps. Containers, typically Docker containers, orchestrated with technologies like Kubernetes, are typically used in DevOps to spin up test targets in test automation. So if you're in that process of evolving your development practices from waterfall to agile, integrating test automation and CI/CD is the logical next step. And containerization should probably be a part of those plans. Evolving to a microservices architecture will help you in that process. But containers can also be useful in your production deployment environment as well, not least because they make it much easier to do things like elastic scalability, where you need to spin up or spin down additional application server instances to get scalability in response to load, instead of having to over-provision for the worst-case scenario upfront. And that's going to become more and more important when you start to deploy in cloud structures and start serving a variable number of customers. So you can see that the OpenEdge reference architecture is somewhat simplistic, even when you factor in microservices. So this is the progress reference architecture for cloud deployment with a modernized application. It envisions more than just the multi-layered architecture or the tiered separation, which is kind of shown here on the right. It also shows all of the other aspects that you need for a modern cloud deployment. And it doesn't really mean that you have to deploy it on a cloud infrastructure. It's really a cloud-ready architecture. You can deploy it on-premise, but it's ready to support cloud clients as well. You're not only providing a browser-based interface for internal clients within the network, but you basically have clients across the public network as well. Now, there's a lot going on this slide, so let's take it step by step. First of all, the application architecture. This is essentially what is represented in the tiered traditional OpenEdge architecture we saw earlier. You can see you have the database, you have your application server tier, which is shown clustered here in this example. And that is serving up different interfaces for clients to consume. Perhaps the most relevant one these days is REST, but we still need to support native ABL clients, SOAP clients, and other types of clients as well. And we certainly still do that. Another important aspect when you start to support clients that are coming over the public internet is you need to worry about the boundaries between your secure internal network and the outside world. At the very least, you're going to want to introduce some kind of an API gateway or a router in the DMZ that is going to become the single entry point for your internal infrastructure from the outside world. Then it will be potentially going through a load balancer, which will spread the load for a clustered application server tier on the backend. You may also need to start integrating with some external systems from your internal systems as well. Usually that is done using REST APIs, because this degree of separation across the internet often is going to mean that you are not going to have direct SQL access or direct secure access to the data yourself. And you need to start consuming external data via REST APIs. You also want to try and externalize the security or the authentication outside of your secure backend or your private network. You want to not only route the request through an API gateway, but you want to authenticate the users that are sending the requests through that gateway as well, before they get into your private network. And we have some various technologies that can do that. You can leverage authentication gateway as a token provider, and Spring Security on PaaSOE can use an external identity provider as well. Another consideration when evolving to a more cloud-friendly architecture or shifting to a cloud deployment model is the impact that may have on data integration. In particular, the challenges of hybrid cloud on-prem integration. The need to potentially expose standardized REST-based access to your data, and the fact that you might want to expose an analytics-friendly interface to your data that still uses access logic and not direct to the database. And of course, user interface and user experience remains a key driver for application evolution. And Progress certainly has great tools and technologies like the Telerik suite and native chat for creating user interfaces for the web, mobile, and even conversational chatbots and UIs. So now that we understand the cloud-enabled architecture, let's take a step back and look at how you can leverage your existing code base without rewriting it from scratch. But before we do that, we need to establish what is object-oriented programming and why you should use it for to your advantage. So, according to Wikipedia, object-oriented programming is a programming paradigm based on the concept of objects, which can contain data in the form of fields, often known as attributes or properties, and code in the form of procedures, often known as methods. A feature of objects is an object's procedure that can access and often modify the data fields on the object with which they are associated. Now, that's a bit vague, so let's take a look at a concrete example. Think of how you can describe a car. What would you use to describe it? So in object-oriented programming, objects are defined in classes. So a car might be described with having make, model, probably power measured in horsepower, and all of those are implemented as fields or properties in object-oriented programming. So you can see the first three fields in this particular class are the ones that describe exactly those things. But a car can also execute some actions, like it can be started, stopped, and be driven. Probably turning and braking are important ones as well, but let's stick with those three for now. Actions that an object can execute are defined as methods, which are quite similar to procedures as we are about to see in a bit. So object-oriented programming is actually quite an old concept, started all the way back in the late 50s in MIT. It went through a lot of modernization stages throughout the years, and in the last 20 years, it has been a leading paradigm in almost all modern languages. It's at the base of a number of different software development principles and can be leveraged to achieve highly scalable and testable architecture for complex business applications. But how can we actually do that? Going into details on object-oriented programming will take way more than the time we have today, but let's mention some of the concepts that will help achieve the scalability and testability that we mentioned. The first principle that object-oriented programming is introducing is called inheritance. Inheritance lets you extend your classes with adding additional behavior or fields. If we take our car example and think of how we can make it a bit more extensible, We can think in lines of how we can extract certain properties that are common amongst different types of objects as well. So this is how we come up with a definition for a vehicle that contains two properties and one action. Then we can use that to expand it a bit into a car via inheritance. We basically add more actions that are specific to a car but are not necessarily shared by all vehicles. The next principle that can help you achieve high testability and extensibility is called encapsulation. And this is the principle that allows you to have control to actions and properties that our objects have defined. So why would you want to actually do that? One of the object-oriented principles is to only allow control over areas that you pre-approve. So if we take a look at our example of a car or a vehicle, let's have a think about how we actually power on or start a car. First, we need to start our power from the car battery to our starter. Then we need to turn the engine in order for it to become ignited, and then we can shut off the ignition power. Now, you don't need control over all that actions. You just need to basically press a single button, and that will take care of everything. So if we take a look at the three different methods here at the bottom, we can see that they're classified as private. Now that makes sure that only methods within the class can access those particular actions. Okay, so another aspect in the use of design patterns is another aspect in object-oriented programming is the use of design patterns. Most of them are used to enhance testability and scalability and are based on object-oriented programming. For example, dependency injection, a form of inversion of control, lets you dictate what resources a class instance will use depending on external factors. For instance, you might want to have different connection strings for your data access logic depending on whether you are currently testing or in production. Another example would be the singleton pattern. You might want to have a single instance of a particular class serving all of your client sessions to keep data integrity. One such case would be a secure token service within your code. Okay, let's not go any deeper into object-oriented programming. Let's see how you can actually leverage what you already have in terms of procedures to take advantage of what we just learned. So I'm going to switch to Progress Developer Studio for OpenEdge now and show you how you can use procedures to generate a common class for them that can expose them to a unified access layer that can be used in a wider array of applications. For this case, we're going to use two procedures, which in terms, one of them adds two numbers one to another and returns the result. And the second one takes two numbers and powers one with the factor of the other. So what we did with that is implemented a class called math, which basically exposes two methods. The first one adds two numbers, and the second one takes two numbers, powers the first one by the magnitude of the second one, and then returns the result. Now we can easily implement the logic in those methods single-handedly with ABL, but once we already have the logic and procedures, we can easily take advantage of that and use it instead. So if we take a look at the power method, you can just see that we are simply calling the procedure as you would in any other form of ABL. The add numbers procedure is a bit more complicated because we're calling it via handles, but that's still very much relevant to any ABL logic that you might have. So after the class was implemented, we just hooked it up to a simple GUI for .NET form that takes two numbers in numeric up-downs, and then you can use our math library to execute certain logic. For example, if you have 2 and 5, we know that the result of adding the two numbers is 7, and we know that if we take 2 to the power of 5 is 32. Okay, we now have a basic idea of how we can leverage our existing code base and expand it into a more modern code architecture. Let's now take a look at what modern UI development entails and how OpenEdge can be used for it. Or basically how we can move from this to this. For those of you who are familiar with the wider portfolio of OpenEdge, you will notice that the two of the screens here are the admin panel for Pro 2. The first one is basically classic OpenEdge forms, and the second one here is the modern version of it in the web. And that's just a concrete example that Progress has done within in our internal tooling that leverages from the things that I'm about to show you. So as we already talked about, this is the OpenEdge reference architecture. And if we imagine it as a human body, then this would be the head. If we take a look at the cloud deployment architecture, the equivalent would be this part right here. The point I want to make is that all contemporary applications are striving to detach the UI from the backend and be basically UI technology agnostic or adopt a headless architecture. And what that gives you is independence from the backend. You can focus on front-end development without the need to worry about the backend being completed. You can mock up most of the backend business logic and use that as a dummy while the progress on the backend is completed. You are free to choose any front-end technology that can make HTTP requests. You will no longer have to utilize the same developers for ABL and whatever you have chosen as a front-end technology. You can test both backend and front-end separately and have the ability to change and adapt new UIs with ease. You can also seamlessly scale your backend to handle user load, and you have in that lays the foundation for a migration to a software as a service model if you are looking towards that as well. That's okay, but how do we actually start our journey to adopt the headless architecture approach? First, we need to make sure that our business logic is accessible via HTTP or HTTPS requests. The relevant way to do that today is to use REST. And OpenEdge provides several different ways to achieve it, ranging from a point-and-click definition or a JSDO service, which is a JavaScript data object, to a completely customizable backend logic with web handlers. The second step that we already talked about would be to separate our existing logic into separate logical modules that can be then deployed in microservices. This ensures that our application can stay up even if a part of it is down or under maintenance, but also helps to scale areas getting the most traffic and heaviest user loads. After we have done that, we can get to the actual UI and plug in any technology you can think of to our backend. From Progress, you can use Telerik and the UI, which I'm about to show you, but you're by any means not restricted to Progress technologies whatsoever. You can use Angular, React, Vue, Flutter is the new modern thing today for mobile development, and you can use desktop technologies as well, which is a part of the demo that I'm about to show you now. So now that you know what a headless architecture is, let's take a look at the demo where we consume one single service with two different interfaces. What we did here is expose our Sports 2020 database via a REST service and used JSDO to leverage that. What we did after that is connect two different interfaces to it. The first one is a desktop application which shows all of our customers in a data grid. And then when we click around and select different ones, we can see all of their data here down at the bottom. And then we can see their addresses pop up in the minimap. What we might also want to do is expose the same interface via web page, for example. So what we have here is the same data grid connected to the same server, and to show that, we can just edit our lift tours customer, just update his name. When we refresh the page, you can see it's still that. And as soon as we refresh our customers in our desktop application, you can see that the name has already been propagated there as well. Okay, if we can specify the most important points from today, they would be that object-oriented programming is the industry standard for a reason. It gives you the options to write highly testable and scalable code. And as we saw, what a modern business-driven application running on OpenEdge should look like, we now know why having module separation or a headless architecture can help us have a truly flexible solution that can accommodate all kinds of UI technologies. With that, I'd like to move to the question section.
Is there any place we can learn to adapt modern coding from traditional ABL?
So that's a fairly good question. Basically, what we currently have here is that what I showed today is how you can access your existing procedural logic by wrapping it in classes that can then be used by your applications. But that's just one way of going about it. You can easily do a whole facade that can just access your functional logic with your existing resources. I'm not sure that if we have something particular that you can take advantage of as a documentation or a white paper, but I do know that we're currently working on a framework or a document for a framework that can show you what are the steps you need to take to start modernizing your project. So probably the next couple of months, you can see that pop up in our OpenEdge group in LinkedIn.
What is the difference between JSDO and web handler connectivity?
Yeah, so strictly speaking, there is no difference. The difference is that JSDO is predefined and already has a handler implemented for you. The methods it's using to serve up data are exactly the same that web handlers are using. The only benefit you get is everything is predefined, so you can use it as is without the need to write everything yourself. You can easily do the exact same thing with web handlers, but you will have to write a whole bunch more code.